Section 7.3 looks at proving triangles are similar. Now, similar triangles are all around us, and they're often used in architecture because triangles make very strong structures. So we can see the similar triangles here because we have some parallel sides here giving us congruent angles here and here. We've also got the reflexive property down here. And notice that this triangle is also repeated in other places on here. Now, to prove that triangles are similar, it's very easy. We just look at the angles. As long as we have two angles that are the same, then we know that the third angle will also be the same. If all the angles are the same, it's going to give us the same shape. We might have different lengths for the sides, but we're going to have the same shape. So we're going to use this angle-angle postulate. In the first one, we're looking for two angles that match. Notice we're already given the 45. We should also by now recognize vertical angles pretty quickly. So our congruent angles are R and V, and then S. So we can say that these two triangles are SW. Let's check just to make sure. R goes with V, S goes with S, and then W and B are together. So we can say that these are similar by angle-angle, and we use the little similar mark. The second one, if we look at it, notice that we've got a 30 and 70. Here we have 70 and 85. So we need to check our third angle here. Well, 30 and 70 give us 100. To find the third angle, we just subtract from 180. So we know we have an 80-degree angle here. Now, comparing that angle, we can see that these do not match. They're not equal. So no, these are not similar. Other theorems that we have in this section are side-angle-side similarity. And this is similar to the side-angle-side for congruence that we want to check with the included angle. And first, that included angle has to be congruent. But what we're checking with the other sides is the proportion of those parts. So the first one divided by the second one, and then this one over this one. We're looking basically for the smaller, maybe the smaller side over the other smaller side and the longer side over the other longer side. Just making sure that we have matching parts. We can do the same thing with side-side-side similarity, where we're checking the proportions between all three of the sides. Notice that on the top they always have their first picture here over the second picture here. So as long as these are all from the same triangle on the bottom and from the top, or they're all from the same triangle. And if we're getting the same proportion, we know that the triangles are similar. So if we want to show that triangles are similar, we look at these two triangles here. Notice that they've only given us sides here, so we're probably going to check by the side-side-side similarity theorem. We'll check first with our shortest sides. We want to make sure that we're matching the correct parts. Notice that we'll always have the smallest parts with the smallest part and the biggest part with the biggest part. So I'm going to look here. I notice that 6 is my smallest number, and over here 9 is the smallest number. So I'll just put my first one over my second figure, and that simplifies to 2/3. In the second one, I have US over WV because, again, we're looking for the longest side. So longest side here is 10. The longest side here is 15. So, again, we use the first one here over the second one over here. And that also simplifies to 2/3. And then for our final picture, we use the remaining sides. We have a 12 left and an 8 left. The first one over the second one. And that also gives us 2/3. Since we're getting the same ratio for each of these, we know that these are similar by the side-side-side similarity theorem. Next, we'll look at using the side-angle-side similarity theorem. And in this one, notice we have two overlapping triangles. So the first thing we want to do is look for an angle for using side-angle-side. Notice that we have a shared angle here at angle K. So that's going to be congruent for both of those triangles. Next, we need to look at our sides. Now, notice that we have a larger one with a smaller one inside, which means we're looking with this 8, and then for the larger one, we'll need to look at the whole side. So go ahead and add those together. Same thing with down here. We have the 12 and the 3. That's going to give us 15. So looking first at the shortest sides, in the smaller triangle, that's going to give us 8. And we do want to check the 10 and the 15. We see the 10 is the shorter side, and so that simplifies to 4/5. Our longest sides then, we have this 12 here and the 15 down here. So we'll put those together. And we want to check that those proportions are the same. We get 4/5 for both of them. We have an angle between those sides, and so this fits the side-angle-side similarity theorem. So we do have similar triangles Make sure we match in the right order. Let's start at M, go along the shorter side to K, which is our shared angle, and over to N. And that's going to be similar to the next one. Our shorter side again is LK, so we'll start with that. K is a congruent angle, and then across our longer side to P. And then again say Y, and that's by the side angle side similarity theorem. Now these similar triangles can be used in practical problems. They can be used for something called indirect measurement. So in this problem, this guy here wants to know how tall this cliff is. Now it'd be very difficult for him to take a tape measure and go measure the side of this cliff. So we're calling this side X. Now if this is the height of the cliff and we have a right angle down here, then he can form a similar triangle by sticking a mirror down on the ground. So he's got a mirror that he's looking at. It comes down, it bounces up, and he sees in his mirror the top of the hill. And mirrors are going to always reflect at the same angle. So we end up with similar triangles. In this triangle, then, if we're matching the sides, if we're looking for X, let's start with that. And we want to know the matching side. That matching side would be his height, or at least to his eyes anyway, which is 5.5 feet. And we want to match that. Remember, we started with X in the larger triangle, so he's measuring from the mirror to the base of the cliff, which is given to us as 34. So I've put here my larger triangle on top for both of these ratios. And then on the bottom, that 34 is going to correspond to the 6. When we simplify this by multiplying both sides by 5.5, that's going to give us X is about, and we'll have to round it, let's go to the nearest tenth, 31.2. Make sure you answer with the correct units, and that's in feet.